Okay, let's have the solution to problem 54 on space thrust. So this is the plan view or the top view, then this is the elevation view. Take note that the distance between ABC and the lower EDF is 4 meters. So the X direction is right, Y direction is upward, and the Z direction is forward. So let's compute distances first. Distance CF is square root of 2 square, 4 square Y along Y, then along Z 2 square. So distance CF is equal to distance BE also. It is 2 square root of 6. Distance BF is square root of 4 square plus 4 square. Along Y is 4, then along Z 2. So it is equal to 6 meters. Distance AE, this one, along X is 3, along Y 4, and along Z is also 4. So distance AE is square root of 41 meters. Then distance CD, square root of along X1, going to the left 1, along Y is 4, then along Z is also 4, this one. So square root of 33 meters. So we find force in BC to be 0 because at joint C, AC, CD, and CF we lie on a single plane, this plane here on CF, and this is the member that is unique, not on the plane of these three members. Therefore, by the principle discussed on the to facilitate the analysis of space thrust, this member is 0, or summation forces perpendicular to the plane of the three bars equals 0, so this is 0. So we begin at joint B. Summation forces x0. So SBE is rightward, AB or BA is leftward, BC is 0, so BF is leftward. So SBE times 2 over distance, 2 square root of 6, then minus SAB times 1. AB is a plane, so 1 to the left, then distance square root of 1 square plus 2 square or square root of 5. Then minus SBF times 4, going to the left, times 4 over distance 6, then equals 0. Call that equation 1. Summation forces Y at B equals 0, going down positive. All the forces BE and BF are going down, except AB, which is a plane. So SBE times 4 over distance 2 square root of 6 plus SAB times 0, because AB is on the XZ plane. There's no Y movement. 0 over square root of 5. Then plus SBF times 4 over 6 equals 0. So equation 2, then finally summation forces along Z equals 0. So SBE is forward, so SBE times 2 over 2 square root of 6. Then SAB is negative, going in that direction, times 2 over square root of 5. Then plus SBF times 2 over 6, 2 over distance, then equals 30, because this is the positive direction. Equation 3. Solving these three equations simultaneously, and we can find SBE, SAB, and SBF. And they are negative 12.25, it is understood compression. Negative 33.54, compression also. BF is 15 kilonewtons tension. So that's it for the member forces at B, attached at B. SBC is 0. Then we proceed to joint A. Summation forces X equals 0. So let's begin with SAE. SAE times 3 over distance, square root of 41. Then plus SAB, which is negative 33.54 times 1 over square root of 5. Minus SAC times 1 over square root of 5. Then plus 50 plus SAD, which has no x component, so but we involved it, 0 SAD equals 0. So simplifying, SAE 3 over square root of 41 minus SAC 1 over square root of 5 plus 0 SAD equals 33.54 over square root of 5 minus 50 is negative 35. Call that equation 4. Then summation forces y equals 0, downward positive. At A, AE is downward, so let's treat that positive. SAE times 4 over square root of 41 for downward, here 1. SAC is 0 because it is horizontal. So plus SAC times 0 over square root of 5. SAD is going down, so plus 4 SAD divided by distance, square root of 2 square plus 4 square. 0 square root of 0 square plus 4 square plus 2 square, and that's 2 square root of 5. So SAD times 4 over distance 2 square root of 5. Then equals 0. Equation 5. Then summation forces along Z equals 0. So this is the Z direction. SAE is positive times 4 over square root of 41. Then SAB is also positive, but its magnitude is negative. SAC is positive also, times 2 over square root of 5. Then minus SAD times 2 over 2 square root of 5. Then plus SAB, the force of SAB is negative 33.54 times 2 over square root of 5 equals 0. Simplifying, SAE times 4 over square root of 41 plus SAC times 2 over square root of 5 minus SAD times 1 over square root of 5, or you may just write 2 over 2 square root of 5 equals positive 30, equation 6. So solving equations 4, 5, and 6 simultaneously give us the following result. SAE negative 21.34, so it is compression. SAC is 55.9 kilonewtons positive, so it is tension. And SAD is equal to 14.91, so positive, it is also tension. So after A, we proceed to joint C. So let's continue at joint C. Summation forces X equals 0. Take note that BC is 0. So CD is positive. So SCD times 1 over distance, square root of 33. Then CF is going to the left. So minus SCF times 2 over distance 2 square root of 6. Then plus SAC, which has a value of 55.9 times 1 over square root of 5 equals 0. So simplifying, SCD times 1 over square root of 33 minus SCF times 2 over 2 square root of 6 equals negative 25, equation 7. Then summation forces along y equals 0, downward positive. So this is the second equation, and this is enough to solve for, there are actually two unknowns only at C, CF and CD, CD and CF. So SCD times 4 over square root of 33 plus SCF times 4 over 2 square root of 6 and no more equals 0. So solving equation 7 and 8 simultaneously, we have SCD equals negative 47.87 kilonewtons and SCF is 40.82 kilonewtons, so positive tension. Then we proceed to joint D. Whole system, summation forces X equals 0 to solve for HDX. So 50, assuming HDX is rightward, HDX plus 50 equals 0, so HDX is negative, so its dx is going to the left. Then summation of moment about f equals 0, fex equals 0, this one. To solve for vertical reaction at D, this one. So by right thumb rule, V sub D, assuming V sub D is upward, this one. And the other vertical reactions are VF and VE. So since we sum up moment about FEX, they are not involved. Its DX is parallel to, so not involved. So the involved force would be V sub D and 30 only. Remember, 30 kilonewtons is 4 meters above the plane of EDF or DEF. So V sub D times 6 by right thumb rule equals 30 times 4. So that's the equation. Or minus 30 times 4 equals 0. So the vertical reaction at D is 20 kilonewtons and it is upward here. Then at D, summation forces X, there are only two unknowns at D, DE and DF. So SDE times 3 over distance, square root of 3 square plus 6 square. That would be 3 over 3 square root of 5, the distance, square root of 3 square plus 6 square. Minus SDF with the same distance times 3 over 3 square root of 5. Then remember SDX, its dx is leftward. So minus 50 or minus SCD. SCD is negative 47.87 times 1 divided by distance square root of 33. Then minus its dx, which is 50, equals 0. So simplifying, SDE times 1 over square root of 5 minus SDF times 1 over square root of 5 equals 50 minus 47.87 over square root of 33. That would be 41.667. Equation 9. Then another equation, summation forces along Z at D equals 0. So that the same unknowns are involved. Not along Y because they have no components. We'll just check later summation forces Y. So SDE times 6 over 3 square root of 5 plus SDF, because it is in the positive Z direction, times 6 over 3 square root of 5, then plus SCD, which is negative 47.87 times 4 over square root of 33, plus SDA or SAD, which is in this direction. The magnitude was positive 14.91 times 2 over 2 square root of 5, the distance of AD equals 0. So simplifying, SDE times 6 over 3 square root of 5 or 2 over square root of 5 plus SDF times 2 over square root of 5, or you just copy, then equals 47.87 times 4 over square root of 33 minus 14.91 divided by square root of 5. So that would be 26.664. So solving equations 9 and 10 simultaneously, then we have SDE equals 61.49, so it is positive tension, and SDF is equal to negative 31.68 kilonewtons. So let's check the summation forces Y to validate our answers. So summation forces Y equals V sub D upward 20, upward CD, so but its magnitude is negative 47.87 times 4 over square root of 33. 4 is the vertical component of distance over distance. And SAD is positive 14.91 times 4 over 2 square root of 5. Then check if it is 0 or almost 0, so almost 0, okay. Then we solve for VF by summation moment about EZ. Here, your right thumb must be pointing your face, and the curling of the forefinger would be in that direction, positive. So if V sub F is assumed upward, positive, so it's negative. So V sub F times 6, assuming V sub F is going down, or yes, plus 50 going up, assuming doing up, positive in that direction. So VF times 6 plus 50 times 4 plus 20 V sub D times 3. Then no more, equals 0. So V sub F is negative 130 over 3, or V sub F is 43.33 kilonewtons. It's not upward but rather downward. And summation moment about EY, so it's here, pointing us positive in that direction to solve for HFG. So HFG, assuming in the positive direction, times 6, then HDX is to the left, so plus, same moment about this EY. Y is pointing our eyes, so positive in that direction. So plus 50 times 6, then minus 50 times 4, or equals 50 times 4 plus 30 times 2. So it's like clockwise. So no more. Then we can solve HFG equals negative 6.667. So therefore, we assume that HFG is in this direction, in the positive direction, but it's not. It's in the opposite direction. So therefore, if we sum up forces along Z whole system, 6.67 in that direction plus 30, 36.67. Therefore, HEZ is 36.667 in the positive Z direction. So summation forces Z equals 0. HEZ in the positive Z direction equals HFG, which is in the negative direction, plus 30. So HEZ is 36.667 kilonewtons in the positive direction. So we only miss V sub E. We sum up moment about FG equals 0 here. Z axis is pointing our eyes. So positive in that direction. So let's assume V sub E is positive. So V sub E times 6 plus V sub D, which is 20 times 3, then equals 50 times 4. Solving for V sub E is 23.33 kilonewtons. So if we check summation forces Y whole system, if this 0, so V sub F is negative 43.33 plus 20, so negative 23.33, then plus 23.33 equals 0. Summation forces X 0, so HDX is 50 to the left. Summation forces along Z, so HFG and HEG. HFG is 6.67 in that direction, plus 30, 36.67. That's why HEG is 36.667 in the positive direction. Then we have one more member, EF. At F, summation forces along X equals 0. So we have HEF or SEF plus SBF with a magnitude of 15, then 4 over distance 6, plus SCF, which is positive 40.82 times 2 over distance. Distance of SCF is 2 square root of 6. Then plus SDF. SDF is negative 31.68 times 3 over distance, 3 over square root of 5, then equals 0. So solving for SEF, SEF is negative 12.5 kilonewtons. So that completes the solution to this problem. Now, you have to perform checking at other joints, like at F, summation forces Y, if it is really 0. At E, summation forces along Z also, if it is 0. Then at E, you check summation forces X, Y, and Z. So that's the only time when summation forces X, Y, and Z are all 0, where we are conveniently solve this problem, but actually these are really the answers. So you just check if the joints E, F, summation forces Y at E, summation forces along Z at F and at E will be 0. And that's it for this problem.